All right, today we're going to cover doing one-step mole conversions. The mole, again, is a unit in chemistry that ties together many important units that would be helpful for when you're trying to see how matter changes within a chemical reaction. That we'll get more in depth with next semester. But this is a little handy chart that kind of helps you lay out your T-chart, the thing you use to do your conversions, and how the mole relates to things like measurements like the mass, which is grams. Here where it says PT, it means refer to your periodic table. The periodic table masses. So the masses for each element that you're working with in the particular problem. So that's what the PT means. Okay. So 1 mole is equal to the molar mass of the particular element you're working with. So that can go between mass and mole. Mole can tie together to the number of like atoms, molecules, or particles that you're working with for a particular substance. So that conversion is always the same. No calculation needed for that one. This one's always for every 1 mole of your substance, you have 6.02 times 10 to the 23rd atoms of it, molecules of it, or particles of it. And then the mole can tie together into volume, which is liters. That's the unit, again, we use for liters. So, again, this one, not like the mass one, no calculation needed. 1 mole is always equal to 22.4 liters of like a gas or liquid of your substance here. Okay, so that conversion is used to tie together mole to volume. Okay, so we're going to see how this looks like now in a T-chart. Okay, so for example, first problems we'll do are moles to mass or mass to mole. So again, 1 mole is equal to the molar mass from the periodic table. Okay, the first one's a little easier, just to kind of get our, get used to working with mass here. It says determine the number of moles in 25.5 grams of silver. So this is your given. This is your unknown. This is what you're trying to figure out, the number of moles. So we're going to set up a T-chart. And you always put what you're given in the top left. So you put the number, the unit, and the label, the substance. Okay. So 25.5 grams of silver. And right away, put what you're trying to get to. So we're going to go to moles of silver. That gives you a point right away when we're doing like quizzes or tests, so you might as well get that point in case you make some mistakes in here. At least you get a point for setting up the problem. All right, so how to go from grams of silver to moles of silver. When you're setting up a T-chart, you always put the unit you want to get rid of on the bottom. So right now we want to get rid of grams of silver. When you divide by grams of silver, they would cancel out. Okay, that's the whole kind of pattern of a T-chart. But to use the little tool that we had before, we are starting at mass and we're going to moles. So here we're starting at mass, we're going to moles. So if I use the arrow that goes from mass to moles, it says put your molar mass, the periodic table mass, on the bottom and put 1 mole on top. So that's going to be our conversion factor that gets us from mass to moles. Okay. So before we look up the mass of silver, I know right away, well, if I have grams of silver on top and I'm going to get rid of it, grams of silver will go on the bottom. And I know from my tool that we had that we have 1 mole of silver. Okay, so it's just like saying for every 1 dozen, you have like 12 eggs. Well, here for every 1 mole of silver, we're going to have the particular mass of silver that's on the periodic table. So if we look up the mass of silver, it's 108. So we're going to put 108 down here. Okay, so to do this calculation, you multiply the numbers on top, and just to kind of verify that things canceled out, grams of silver matches grams of silver. We're at moles of silver, which is matching moles of silver here. Okay, so we're going to multiply the top numbers, 25.5 times 1, okay, divided by, get the glare out of here, divided by 108. All right, so our answer is 0.236 moles of silver. Okay, now for a little more difficult one is if we're working with a compound. here it says determine the mass. So this is your unknown. If determine the mass, sorry, that's the mass is unknown. The 0.54 moles is your given. Okay. So that's going to go in the top left, the 0.54 mole, and we need to write PbCl4. And it's saying, well, what's the mass of it? So I want to figure out the gram. So right away I'm going to put the unit and label at the end so I make sure I get at least a point on this problem. Okay, so right now I have moles. I'm trying to get to grams. I need to cancel out moles, but just to verify my step here, I'm going from moles to mass. So mole to mass, I see that 1 mole goes in the bottom to cancel out the moles on the top, and the molar mass goes on the top. Okay, so to get rid of the moles that is given to you on the top, we need to get rid of mole. So we put that right on the bottom. So you're always going to see this pattern of the same unit diagonal is going to match. If it doesn't match, it means you set the problem up incorrectly. So we're 1 mole PbCl4. We're going to put the grams of PbCl4 on the top. Now this one's not as easy as the previous one because we have a compound here where we have to calculate the total mass of this whole thing. So to do this, you take your compound. We have lead and we have chlorine in it. You count how many beats you have. So lead, I don't see a subscript after it, so it means I have 1 of it. Chlorine, I see I have 4 of those. So I have 4 chlorines. And then we find the masses on the periodic table. So Pb, lead, is 207. We put 207. And then chlorine is 35. So we're going to put the 35 here. Oops. That's a 35. Okay. So 207 times 1 is 207. 4 times 35 is 140. And then you add up that total. So 140 plus 207, you get 347. And that's what goes here. So that's the total mass. So these problems with the molar masses with the compounds are a little more difficult because you have to kind of do this little side calculation. I see moles on top matches moles on bottom, which means when we divide by those, they cancel out. I'm left in grams, which is what I wanted. Last step to do is to do the math here. The numbers on top you multiply. So 0.54 times 347. Okay, so we get 187.4 divided by 1. Well, that's going to be the same thing. Okay, 187. We're going to round that to 187. So that would be your answer for this one. All right, so that was a little more difficult one. The next 2 are a little easier because we're working with consistent numbers here. This next set is doing moles to particles. Okay. So moles to particles, we see for every 1 mole, you're always going to have what we call Avogadro's number, named after the scientist, 6.02 times 10 to the 23. So that's going to be our number that we're working with for this set. All right, so the first problem says how many particles, that's our unknown, are in 11.5 moles of silver. That's your given. The given goes in the top left. And again, you can pause this whenever you need to if things are going fast. That's your given, goes in the top left. Particles goes at the end here. That's what we're going to go to. So put that at the end right away to get your points at least. All right, moles to particles. So here's your mole. Here's the particles. So to set up your conversion factor, mole to particle, 1 mole on the bottom, and then 6.02 times 10 to the 23rd on the top. Okay. So moles on top, so you need to cancel that out. So 1 mole silver on the bottom. And then we put in that constant number, 6.02 times 10 to the 23rd particles silver. The moles match, so that means that they cancel out, because when you divide by like terms, they cancel out. Now to do the math for this one, same idea. We multiply these top 2 numbers, but just a reminder on how to type in a number like this with an exponent. Okay, so 11.5. All right, now the 6.02, you just type in 6.02, but then the times 10 part, again, you need to use that second EE function. So here's the second button. Here's the EE, so it says EE. You press that, and you see 1 capital E pop up. Okay, that means times 10 too. And then we're going to do to the 23rd. Okay, so here's what it looks like when you type it in, 11.56. Oops, I forgot my time sign. Okay, times 6.02, second by E, 23rd. Okay, that's what it will look like. Press enter, and that's your number there. Divide by 1, which won't change your answer. It's still going to be 6.96 times 10 to the 24th. So we need to include this part. Okay, so 6.96 times 10 to the 24th. That is your answer. Okay. All right, let's do one more of those. How many moles, so that's going to be our unknown, are in 3.4 times 10 to the 22nd particles? That's your given. So the given goes in the top left. 3.4 times 10 to the 22nd particles